By now, we already mastered the derivation and we know all the derivation properties, and we are able to solve any derivation related problem. We are ready to jump into integration and the antiderivative. So you can imagine the integration as the opposite of derivation. Before you say x squared derivation equals 2x. In this case, if I tell you what is the integration of 2x, that's x squared, with the little details that we will learn more about as we're moving forward. So if I want to identify for you the integration concept, imagine you have this table lamp over here, or this side lamp, corner lamp, whatever you call it. It is 15 inches tall, and we want to measure or calculate the volume of the base of that lamp. What you're gonna do? You're gonna use integration in order to do that. Integration basically slices the object into infinite number of cross-sectional bits, if you would say. So as we say here, we have the base of the lamp being sectioned. Imagine this lamp as a 3D object. Each section represents a disc shape in this case. Then you can calculate the area of that specific shape. Then you go to the next shape and calculate the area of that shape. Let's say it's a cylindrical shape. Then you use cylindrical area equation in order to find that area. In order to find the area of the overall base of that lamp, then you do the summation of all the areas of those cross sections that you created along the lamp base. That's exactly what we call integration. So if you imagine integration have this symbol. So you have the integration of dB equals B. dB means each little section that you did, that's represented as a dB. We usually do the integration from a certain area to a different area. So when you have an integration that doesn't have a borders at the top and the bottom, then we call it indefinite integration. Means integration that is generalized and doesn't have a borders. But the more famous type of integration, that integration have a start and end point, or a top and a bottom point. In this case, we call it definite integration or border defined integration. As you can see here, you are slicing the base of the lamp from top to bottom. Then you call it a definite integration. You already identified where you want to apply the integration and which area you want to slice in order to find the total area of the base of that lamp. Now, the theories say the antiderivative of f of x is the set of function f of x plus c such that the d of f of x plus c over dx equals the f of x. So we start with you with a simpler concept of integration, which is antiderivative, which is the opposite of derivative. Like if you have a derivative in front of you, you want to go back to its origin or its source. In this case, you are having the f of x plus c as the derivative. Then what's the antiderivative for that? That's f of x. The constant c here, we call it the constant of integration, because now we're talking about a simpler concept of integration. Usually when you do integration, you will end up with the basic function before it's being derived, plus a constant, which is the constant of integration. So you can see here, the integration of the function f of x dx equals f of x plus c. You can see here small f and here capital F. That's what we call indefinite integral, because we don't have top and bottom limitation or top and bottom points or boundaries for that integration. So the generalized form of the integration would be looking like the integration symbol over here of the function f of x dx, which means with respect to x will give you, the result will be f capital of x plus c. If you feel confused again, that's fine. You will learn and you will have more sense about the integration as moving forward with the examples. Now we have the integration, indefinite integration in this case, of d of x. What is the integration of 8? You will have a table of integration rules in a second. and you'll be able to solve these. So 8, you can ask yourself, if 8 is a derivative, what was it before derivation? In order to get 8, this function should be 8x. When you derive the 8x, then you will get 8. As simple as that. That's what we call the antiderivative plus the constant of integration in this case. So if you want to check, derive the function 8x plus c and see what you get. In this case, you get 8. That means your derivation was right. If we have the integration of 3x squared dx, what is the integration of that function? That's x cubed plus c. Why? Because if we derive the function x cubed plus c, you will end up with the function 3x squared. That confirms that your integration is right, even though without using rules. Of course, we have rules because sometimes you get a more complicated problems that need you to go back to the rules and apply them in a systematic way in order to find the correct final answer of that expression. Here, the integration of e of x dx, that would give you e of x plus c. To check, derive that. If it gives you the function f of x, then that means your integration is right. The integration of 1 over x dx equals the ln of x plus c. Again, you want to check, derive the ln of x plus c. It should give you 1 over x. Otherwise, that means your integration is not right. Of course, scientists use that concept and did the anti-derivation on hundreds of functions and start to see the patterns of the results and the solutions of those functions and realize we can give a final form of derivation, or let's say we can have a table of integrals. If you integrate this function in a certain way, you can use this generalized form in order to get the right answer. So the rules of integration, the integration of a constant dx will give you the constant multiplied by x plus the integration factor c. For the power rule, the integration of x to the power of n, remember we had the differentiation for the power rule, now we have the integration for the power rule. The integration of x to the power of n dx will equal 1 over n, which is the power of x, plus 1, multiplied by x to the power of n plus 1 plus c. So whenever you have a function that needs integration in the form of a power rule, then you can go back to the power rule and plug in the variables and the constants that relates to that rule, and you'll be able to deliver your final solution. For the logarithmic expressions, the rule would be the integration of 1 over x dx would equal the ln of x plus c, where x greater than 0. The exponential rule, or the base e, the integration of e to the power of ax dx will equal 1 over a multiplied by e to the power of ax plus c, where a doesn't equal 0. Let's take an example on the rules that we learned for integration. If we have here, obviously, we have a power rule. What's the integration of x to the power of 4 dx? That would be x to the power of n. So x to the power of n would be 1 over n plus 1 multiplied by x to the power of n plus 1. So 1 over 4 plus 1 would be 5, multiplied by x to the power of 4 plus 1, that's x to the power of 5, plus c. To check, you derive the answer. Then if you end up with the function that you are integrating, then that means your solution is right. So you can see here what exactly happened. Firstly, they raise the power by 1, then you divide the term, then you divide the term by the new power. So x to the power of n, that will be 1 over n plus 1 multiplied by x to the power of n plus 1 plus c. Now, if we want to go more confusing, this square root of x dx, right away, as we learn derivation, move that into a power form. This square root of x means it is x to the power of 1 over 2. What is the integration of x to the power of 1 over 2? Apply the power rule. It will be as easy as that. Then you'll end up with x to the power of 3 over 2 over 3 over 2 plus c, which can be simplified as 2 over 3 multiplied by x to the power of 3 over 2 plus c. I hope I'm not moving fast and things are making sense. Whenever you see integration, that's the integration of what we care about is this function f of x. Dx means with respect to x. You don't care about that unless you have many functions with relation to a different variables like dx and dy, etc., then the dx would make sense to pay attention for. But now it's only a form, like the integration and the dx. You just care about the function f of x. What is the integration of f of x? Go back to the table, identify it. It is a power rule in this case. Apply the power rule, you get your final solution, as easy as that. Things, if they are different a little bit, then try to see what kind of rule they relate to. In this case, the square root of x relates to the power rule when you represent it as x to the power of 1 over 2. Now we have the integration of e to the power of 4x dx. We have a function e to the power of 4x. We go back to the integration table or the integration rules, see which rules apply here and how we're gonna integrate the function of e to the power of 4x. If we go back to the integration rules, that means e to the power of a multiplied by x should be 1 over a, which is 1 over 4, multiplied by e to the power of ax, in this case e to the power of 4x plus c. And you get your final answer as easy.